Alright guys, welcome to RC MOJO. Time for another build. What we have here is a Black Horse Super Air, chosen because between the three Air models there's something for everybody, and the three models share a lot of the same or very similar parts. The Speed Air has a trike undercarriage, making it a good follow-on from a trainer. It also has a large straight wing, making it quite good in terms of low speed handling. It gets recommended quite often at clubs as a second model. Next is the Travel Air, similar in almost every way to the Speed Air, except it's a tail dragger. Finally, the Super Air, which is like the Travel Air, a tail dragger, despite the box art, but unlike the other two, it has a tapered wing, making it a bit more aerobatic at the price of low speed handling. In all cases, you need the usual suspects to complete the model. 4 or 5 standard servos, high-tech HS311s are fine, switch harness, 4 or 5 cell receiver pack, a full range receiver, some fuel tube, a 40 or 46 size engine, and of course some thin cyno and some 1 hour epoxy. Why 1 hour epoxy? Well, we're not in a rush, and having a straight flying plane that took a little more time to build is better than an unflyable mess because you couldn't get the bits together before the glue set. Whichever one you choose, I'm sure it'll do you well, as long as you take your time on the build. Even if you have a different model to put together, most of the assembly techniques work just as well for a 50 quid trainer or a fancy ARTF from one of the posh brands. Okay, let's get started. I won't be following the instruction to the letter, as well I don't agree with the build order. It's still a good idea to read through though, so you can see how the bits are supposed to go together. Another thing you'll see a lot of is the need to dry assemble, usually more than once to be 100% sure of a proper fit. The first job is the wings. After an inspection to make sure the ailerons are okay, there's no broken bits and the covering is okay, we need to remove the servo trays. Normally stuck on with a bit of tape, be careful when peeling it off as the PVC covering can rip extremely easily. Now remove the covering from any bits that need it and use a new blade to avoid tearing the covering. First of the dry fits. On this model the undercarriage is wing mounted, so we need to check it fits. Sometimes a slot in the skin might need extending. This time however it's a perfect fit. Next we need to harden the undercarriage slot and block in the wing. With the undercarriage wire removed, as we don't want to glue it in, pour some thin cyno along the slot and down into the hole. This will wick and soak into the wood, making it much stronger. The other reason being the build quality in a lot of ARTFs isn't brilliant, nor is the glue they use, so the thin cyno just makes sure it'll hold. Anyway, before putting anything into the newly hardened area, leave it an hour or so to make sure it's fully set. And while it's setting, let's put together one of the aileron servo mounts. You'll need to extend the servo wires in most builds, and we just so happen to have a video dedicated to the subject, link in the description below. First cut the covering for the servo arm, again sharp knife so the covering doesn't tear. Now take the round servo off the servo, connect it to a servo tester to centre it, or if you haven't got one, connect it up to your radio, and make sure all the trims are set to neutral. Your servos will come with a few different arms, we want a straight one, and high-tech servos come with a nice adjustable length one. Usable on ailerons on sport models up to 60 size, don't use them on anything bigger, and don't use them for the rudder as they aren't as strong as the regular ones. If you only have double-ended arms or four-ended arms, you can cut the arms off you don't need. Fit the selected arm and get it as close to straight as you can. Now put the rubber grommets in. These are important as the vibration and over-tightened screws can result in the lugs breaking off the servo, which isn't a good thing. You'll also need to fit the brass ferrules, insert them from the bottom, otherwise they end up being pressed into the wood. The mounting screws that come with servos tend to be very soft, and if you look at them sideways the head's stripped, making it a bit of a faff to get them in and out. So I use these hex head servo screws, much easier to get in and out, and they look a bit more fancy too, which is nice. These ones are a bit short. I've got longer ones on the way, so just pretend they're 14mm long. And now we have another ARTF special, The lugs on the servo tray aren't straight, so you'll stress the servo casing. Also, the glue they use has oozed a bit, making it impossible to mount the servo level. Some would leave it and just put the bits together, but this is a possible point of failure, so it's a good idea to clean it up. First we cut away the glue from the surface, and what do we find? The glue on the surface was all that was holding it together. Not good at all, but that's why we check. Anyway, with the glue cleaned off, the lugs are still tight enough we can mark and drill the holes for the servo. This is another one of those tasks that you need to take your time with. Mark the first hole's position, then drill it to the correct size for the screws. In this case I used a 1.5mm bit. Then mount the servos with a single screw, mark the hole on the opposite side of the servo, remove the servo and drill the hole. Repeat until you've done all four. This might seem a bit long-winded, but all the holes will be perfectly positioned, not stressing the servo at all, and because the mounting lugs were left loose, any misalignment can be taken up by them. The next bit is a little tricky, as we need to tack the lugs onto the cover without gluing them to the servo. So, use a tiny drop of thin cyano and leave it for 10 minutes to dry. Remove the servo again, and it's time to harden the mount. Like the undercarriage slot, pour some thin cyano around the lugs. It will soak in, making them nice and strong. At the same time, you can put a drop on the holes. Again, it will soak in, making the threads that bit stronger. Run a drill bit through the holes in the corner of the cover to clean them out. Lay it in the hole in the wing, mark where the holes want to be on the rails in the wing, pop the cover out and drill the holes to correct size for the screws. I'm using the same hex head servo screws as they look nice. The ones in the kit would also be fine. Fit the cover, screw in the screws to cut the threads and check everything fits. Then, you guessed it, take it all apart again and pour some drops of cyano in the holes, and of course give it time to fully dry before you reassemble. When it's fully dry, refit the servo to the mount and feed the wire through the wing. This kit comes with some string in the wing to help get it through. If it didn't, an easy trick is to tie a weight to the end of the wire and lower it through. Lastly, fit the mounted servo in the wing and put in the 4 screws. Now the control horn. Use a square to mark the centre of the horn position. Take the line from the servo arm and move it about 2mm towards the outside of the wing to account for the bend that will be in the wire. If you have the more traditional horn, hold it over the line and drill 2 holes. The horn included in the kit is a nice looking multi-part one. The first step is to drill a 6mm hole, but because balsa is soft you need to start with a small hole, 2mm, and go up in steps to stop the drill from wandering. Once drilled, clean up the covering and fit the 2 plastic parts. Put one of the long M3 screws through and hold it together with 2 nuts. Then the plastic adapter goes on the end. Screw it on until there's just a little bit of thread poking out the end. Next you need to take one of the push rods and thread a clevis on the threaded end. Again, thread it on until there's just a little bit of thread sticking right the way through. Drill the outermost hole in the servo arm to fit the wire. In this case it's 2mm. Clip the clevis onto the horn and mark the rod where it meets the servo arm hole. Take it off and bend it 90 degrees. Do a test fit. If it's off by a tiny bit, don't worry. Remove it and clip on a swing keeper. Mark where you need to cut, take the keeper off and file a groove all the way around the wire and snap it off. If you're left with a sharp end, file it smooth. Using a small bit of fuel tube, pop it over the clevis so it can't come undone in flight. Put it all together, connect it up to a servo tester, and behold, your working aileron. Last little bit left to do to get this wing ready, and that's to get the undercarriage fitted. Pop the wire into the slot, take 2 of the saddle clamps, position them 10 or 15mm from each end, and mark where the holes want to be. Take out the wire and drill it to fit the screws, 1.5mm in this case. Then dry assemble and make sure everything fits nicely. And now again it's time to take it apart so we can harden up the holes with some cyano. This time however, don't bother putting it back together right away, as it's easier to glue the 2 wing panels together without the undercarriage fitted. Which reminds me, in case you hadn't guessed, you need to do all that again on the other wing panel, but you know what you're doing now, so it shouldn't take long at all. Great. Right, Time to glue the panels together. First step is, if you can, put the wings together dry and fit them to the fuselage and check for any misalignments, huge gaps, and generally anything that doesn't look right. This kit, however, was perfect, so no worries this time. Take it apart again and mix up some 1 hour epoxy. Why 1 hour? Well, it stays viscous for ages, so it flows nicely between the parts, giving a good strong joint. It also means if, like me, it starts going off while you're still pasting it on the centre rib, you still have a good chance of getting it together, even if it's gone a bit stiff. Anyway, put a layer of epoxy on the rib, not so much that it runs over the edges, but enough that you can get a good even coat, and put a generous amount down the wing brace hole. If you have the more traditional plywood brace with the square hole, make sure you get glue on all the surfaces. Stuff the brace in the hole. If it's round, twist it as you go to help spread the glue. Apply the glue to the other panel in the same way. I'm starting to hurry here as it's going a bit stiff, but with a bit of pressure the two panels met up quite nicely. If the epoxy is still nice and thin, they should slide together quite freely. Now, you need to keep a bit of pressure on the panels while the epoxy sets. You can put a rubber band over the pegs on the leading edge to pull it together at the front, and put the two wing screws halfway through their holes at the back with a rubber band to pull the trailing edge together. With a good fitting round wing brace, you can get away with a bulldog clip on the trailing edge to keep them aligned. You just need to wipe the excess glue off as it very slowly oozes out over the next couple of hours. With the more traditional plywood brace, you'll need to put the wing flat on the surface and brace the wing so it's held in the right position while it dries. When it's completely hardened, wrap the centre in some tape to make it look nice, pop the undercarriage back on, fit the collets and wheels, not forgetting to use a little bit of Loctite on the grub screws, and we're done. One wing complete. That's it for part 1. Next time we'll build up the fuzz, fit servos, and if there's time, fit the engine and get it ready for the flight line. If not, well, this will end up a 3-parter. If you like this video, why not hit the like button to let us know. And of course there's rcmojo.com where there's some nice pictures and stuff to read. Thanks for watching.